Hi there. In today's video, we'll be looking at equations of motion. Now you know that acceleration A is change in velocity over time. Now, of course, we know that we have two velocities. We have initial velocity u. This is the initial velocity of a body. Now, v, a final velocity, v. Now, so when we say a change in velocity, we're talking about the difference between the final velocity and the initial velocity. Okay, so that's going to be A, acceleration is going to be v minus u over t. Okay, so now let's cross multiply here. So v minus u is going to be equal to A times t gives us at. V minus u is equal to 80. Now if you take u to this side, is minus here, becomes plus here, so it becomes v is equal to u plus at, and that will be our first equation of motion. Is our first equation of motion. V is equal to u plus 80. Now we know that distance s is average velocity times time. Now, of course, when you say average velocity, you're actually talking about the average of maybe two or more things. So when we say average velocity, we have two velocities. That's going to be the addition of velocity divided by 2. Okay, so distance s is equal to average velocity, that's v plus u divided by 2 multiplied by time t. So this becomes, we recall that v is equal to u plus 80. Here, v is equal to u plus 80 from equation 1. Here, we're going to recall that v is equal to u plus 80. So this becomes s is equal to, anywhere I see v, I replace it with u plus 80. It becomes u plus 80 plus u over 2 multiplied by time. Now, this becomes s is equal to u plus u gives us 2u plus 80 over 2 multiplied by time. Okay, multiplied by time. Now we're going to multiply this with this t, so this becomes s is equal to 2ut plus 80 squared over 2. Okay, and then we could split this to become s is equal to 2 can divide this and divide this, becomes 2ut over 2 plus 80 squared over 2. Now 2 takes away 2 here, so we have s is equal to ut plus, this can be written into half at squared. Okay, half at squared. So this is our second equation of motion. This is our second equation of motion. S is equal to ut plus half at squared. Now we also know that remove all this part. Okay, now we also know that s, from s, distance s is v plus u over 2 times time. Now from equation 1, we're going to make t the subject of formula. Make t the subject. We're going to make t the subject from equation 1 over here. We're going to make t the subject. Now if we make t the subject from there, t is going to be equal to v minus u over a. Okay, t is going to be equal to v minus u over a. If we should make t the subject of formula. So from there, we have t is equal to v minus u. Now, you have your distance s to be equal to v plus u over 2 times time. Now, you could replace this t with this v minus u over a. So this becomes s, distance s, is equal to v plus u over 2 times t, that's v minus u over a. Now multiply this with this. This is v times v, that gives you v squared. V times minus u, that gives you minus uv. U times v, that gives you plus uv. And this times this gives you minus u squared over 2 multiplied by a, that gives us 2a. And then this becomes s is equal to, now if you check this out very well, you notice that minus uv can take away plus uv. You will notice that. And so we're going to have v squared minus u squared over 2a. Now cross multiply from here. This becomes v squared minus u squared is equal to 2as. Okay, now take this u squared to this side. It becomes v squared is equal to u squared plus 2as. And that gives us the third equation of motion, that v squared is equal to u squared plus 2as. Hope you understand that.